Hi, I'm Ben with Weber State Science in the Park program. One of the more popular activities with especially the older kids is our building circuits. For building circuits we have this pegboard, and then we just use some bolts and nuts to keep the bolts in place, and we created an array here just for ease. You don't necessarily need all this at home, but if you're trying to make a pretty complicated circuit, this definitely makes things easier. You can get all these things at your local hardware store, whether you go to Lowe's or Home Depot or whatever. So this is just a pegboard, and then just you can get a bolt that's, it doesn't have to be, this is probably 3 or 4 inches, but if you were just to do something like 2 inches, that'd probably work too. And then you also need a hand crank generator. Now these vary in price quite a bit online. That's probably the best place to get them is online. They can vary from about $15 to $60, so there's a big gap in between prices and quality as well. So just these I think are one of the more expensive kind, but we have a lot of kids use them and we need something pretty durable. But at home, if you're taking care of them, you could probably get one of the more cheaper ones and it'll be just fine. We also have little just DC motors, and then we've taped, just using duct tape, different flags on it so they can see the motor spinning whenever they crank the generator. We also have these little 1.5 volt light bulbs, and then this is, they don't really come, they come in a 5-pack for a couple dollars, and then this is a receptacle or a screw base, the black part, and that just makes it a little easier to use the light bulb. And then the bases are a little more expensive than the light bulb, but still you can get a couple of these for less than $5. We also have capacitors, which are really fun. I like to tell the kids that the capacitors are kind of like a battery. So whenever they're cranking, they're putting a charge onto the capacitor, and then the capacitor is charging, and then when they let go, the generator starts spinning because it's sending the electricity back. So this is a capacitor. It's a this is a 1.0 farad, F-A-R-A-D, if you're going to look that up, and then 5 volt. And you can also find these online. These are probably a little more expensive than some of the other things, but still maybe $5 for this little guy right here. We also have alligator clips or test leads. You can get these also at your local hardware store. They come in usually about a 10-pack for $5, and you can also find these online as well. Another thing that's really fun for the kids is this is just a computer fan to keep your motherboard or your processor cool. These come in packs of 4 for relatively cheap, maybe $10 for the pack, but you could probably find some that are even cheaper than that. A lot of them come with the plug to go right into the motherboard or whatever, and so we just took that off. You only need the black and the red wires. Then I've attached these alligator clips on there just for ease. So when you're building your circuits, there's 2 main types, and then you can combine, make any number of combinations. But the first type I'm going to show you is series. Now it's pretty easy. All the kids, 5-year-olds have really no problem eventually figuring out that you need the 2 leads to go on to the 2 ends of the light bulb, and they twist. And sometimes they try different things. They might put it, and there's like these holes in the base. I don't know if you can see them. Sometimes they'll put them in both the holes, but we just encourage them to keep trying, and they eventually figure it out. So doing the 1 light bulb is pretty easy. The next thing that I like to do is give them the challenge to do two things at the same time. And so, like I said, there's two main ways of setting this up. So you can either do in series. So in series, I think of it like a necklace. It's just one big loop, and these are each like the beads in your necklace. And so you can just make a big loop, and then the electricity is going to run from your generator, from one light bulb through this lead into the other light bulb and then back in. And so that's, well, we can't really see that second light bulb. Let's get these a little close together. Now they're right next to each other. Okay, both of them are going. So that's one way. That's called series. Now another way of lighting things up is in parallel. So I've set up these alligator clips already. When you're doing series, you really don't, like I said, this pegboard isn't all that necessary, but when you're trying to do parallel, that makes it a lot easier. So I'm going to take the two leads, and I've already attached some leads to this bolt right here. So I can take a pair and run it to one light bulb, and that's going to work. There you go. Then I can just start adding, doing the exact same thing. Now there's two, so we have a pair, well, yeah, that will still work. A pair of clips going to each light bulb. Let's get these so you can see them. Both right there. This is pretty common too, especially when you drop the generator. This plug comes out, and so kids start spinning and nothing happens. So that's one of the first things we check is, oh, the end came out. So both lights are going, and that's called a parallel series. And so we can add another pair of things, or another thing with this other pair. But that just kind of gives you an idea of what the light bulbs look like. This is our little motor. Just get the alligator clips on those. Stand. Okay, so this is directional depending on what way you spin your generator. So that's also something cool for the kids to see. And oh wow, when I do that or that way. And it doesn't matter for the light bulbs, they're going to light up either way. You can kind of see the light bulbs. As you add things, of course it takes a lot more energy. So it takes a lot more spinning to get them all to go at once. This is our, like I said, this is our fan. I'm going to detach all of these. Now the fan is a little tricky because it is directional, meaning that it only spins one direction. And if you're spinning the generator in the wrong direction, it won't spin. So I'll set that right there. That's pretty easy for you to see. So right now I'm spinning it, I guess clockwise. When I spin it counterclockwise, it's not really working. But there's clockwise. Now, just depending on how your circuit's set up, it might work counterclockwise. For instance, if I switch the leads that are going to each wire, then it will change the direction or flow of the electricity into it. And so, but the fan is always going to spin in the same direction regardless. And another really cool thing the kids like to do is play with the capacitor. So, let me get a couple clips on the capacitor. Oh, I guess I didn't really have to do that. I can just use the clips from the generator. So as I'm spinning, really, I mean, it's not doing anything, and so the kids are like, oh, this is kind of dumb, whatever. Then I tell them to let go of the generator, and whoa, it keeps going. So the capacitor is, like I said, we were charging it as I was cranking, and now it's giving the electricity right back to the generator and spinning it. And of course you can put these in a circuit with other things and stop cranking and it'll still keep things going. Like the motor will keep turning or the light bulb will stay lit even though I stop cranking. So that's just some of the things that the kids like to do with circuits. Hopefully you can do some of these at home. They're really fun. And we'll see you next time.